See, before talking about this addresses and then the sizes, pages, everything, you should be really be comfortable with the binary numbers. And I really suggest that you go to the subnetting concept of computer networks, finish it, and then come to this section because there I discussed about how to use binary numbers. Okay, one thing is you should be very good with the powers of 2. See this. So what is 2 power 1, 2 power 2, 2 power 3, and till 2 power 10 it should be on your fingertips, right? I mean till 2 power 9. There it is very easy and straightforward, but then I did some mistakes in gate and I still remember that. You know what? I did this mistake. 2 power 20 divided by 2. I have written it as 2 power 10. I know that it is 2 power 19, but then at that moment when I was taking my test, and I didn't remember it. So if I would have done that question right, I would have ended up in maybe single digit rank. So that is the difference. Even though we know some things well, we'll not be able to apply them because we don't practice them much. We just overlook, right? So what I would like to suggest is, even though the things might look very simple, practice them till you don't get them wrong. That is still the point. You should practice. Yes, we all know many things, but then given that 3 hours of time on that particular day, in that particular place, you should be able to do it well. So only practice will help you, right? So let's do as many questions as possible, but you should be really careful. Be careful with these numbers. 2 power 1, and in computer science, everything is about powers of 2, right? And it is 2 power 1, 2 power 3, so on, 2 power 9, and then 2 power 10, we call it as kilo, K, and 2 power 20, it is called as mega, M, and 2 power 30 it is called as giga, and 2 power 40 is called as tera. Just remember these numbers, and the conversion should be very straightforward. See, maybe I'll just write down. 2 power 1 is 2, 2 power 2 is 4, and 2 power 3 is 8, 2 power 4 is 16, 2 power 5 is 32, 2 power 6 is 64, 2 power 7 is 128, 2 power 8 is 256, 2 power 9 is 512, right? So only with these numbers the many questions will be asked. Now if they say that the number of some number, see, if they say that the memory is 128 GB, right? If the memory is 128 GB, how could you convert it to 2 powers? So we know that 128 is 2 power 7, and check that G is 2 power 30, right? Therefore it is 2 power 37. Excuse me. And now if you want to know how much is 2 power 28, then you write it like this: 2 power 8 into 2 power 20. And what is 2 power 8? 2 power 8 is 256, we know that, and 2 power 20 is m, right? Therefore it is 256 m. If the memory is 2 power 8, this bytes. So that is how you could convert bits to this powers of 2's to some number, and some number to powers of 2's. Generally memory will be given in MB, GB, TB like this, right? And then the address will be given in bits. So once you convert it, then you will understand how many bits are required. And I think you know this. So using one bit, we can generate two numbers, 0 and 1, right? Therefore using one bit we can address two units, and using 2 bits we can generate 4 numbers, 0 1 1 0 1 1. Therefore we can address 4 parts or 4 bytes or 4 units. If each number is going to be addressed for 1 unit, then using 2 bits we can address 4 units, isn't it? And using 3 bits, right, 0 0 0 so on, 1 1 1, so I can address 8 units. Then using n bits I can address 2 power n units, isn't it, right? And now you please watch that video on in YouTube about this or even in this website, about that IP addresses, and I think in IP addresses. So the initial parts of the computer networks, they contain IP addresses. There I have discussed in detail about how to split the numbers and about binary numbers completely, and you please refer to that. Okay, so if I have a n bit number, right, and if I break it into 2 parts of, let us say, k bits and n minus k bits, right? Then these k bits can be used as, this is nothing but dividing the entire number space into 2 power k parts in such a way that each part size is, n 2 power n minus k, which means if I have n bit number, the total number of the total address space possible is 2 power n, isn't it? Now if I break it into two parts in such a way that the first part contains k bits and the second part contains n minus k bits, right? Then it is nothing but dividing the entire address space into 2 power k parts in such a way that size of each part is 2 power n minus k, right? Now check this, 2 power k into 2 power n minus k is again going to give you 2 power n, right? And in case of computer networks, I told you that this is the network ID and this is the size of the network, right? Or the number of IP addresses in the network. In case of this operating systems, we can think of this as, this is the page this is the page number and this is the size of the page, or this is the frame number and this is the size of the frame, right? And moreover, I told you there in computer networks that whenever we have either the size of a network or size of a page is always going to be a power of 2. The reason why I have taken everything to be a power of 2, right? Here also you are going to see that a size of a page is always going to be 128 bytes, or size of a block is going to be 128 or 512, something like this. Why should always we use size of a power of 2 as the size of a unit here? In any computer science subject, right? We are going to use only powers of 2 as the size of a unit. Why should we use it is, if I have a n bit number, right, and if I want to break it into two parts, right, then if I have power of 2 as the size of the units, then the breaking will be very easy. In some sense, what I mean to say is, if I have a n bit number, right, and if I divide it with 2 power k, then the remainder is nothing but the least significant k bits, and the quotient is nothing but the most significant n minus k bit. This part also I explained there. Therefore here always a size of the page is 2 power k, because we want to divide the address by the size of a page and we want to take out the remainder, and that is going to be the offset, right? Therefore, if you want to find out the division without actually dividing the number, then the best approach is, if we want to find out the number without dividing it, right, then the best approach is breaking down this, right? And this will be possible only when the size of the page is 2 power k. That is why you will always see that the size of the page is 2 power k. Using this, we need not actually perform the division. We can write the address in some register and we can just read whatever part we want, and we can mask out the other part. What is masking? You can just put 0 0 0 0 all here and then 1 1 1 1 all here, and when you mask it, you are going to get only the offset. Getting this? So whatever it is, we always are interested in powers of 2, right? Since the number system here contains 0 and 1, whenever we do every arithmetic in powers of 2, it will be straightforward and easy, right? So about these basics, I have already covered them in computer networks. You please watch them and then I can come back, okay? So in case you are registered only for operating systems, I think these basics are going to be good enough, right? So what is it? If I have a n bit number and if I divide it into two parts, right, first part is going to give you 2 power k parts and second part is going to give you 2 power those many remaining bits, right? And generally we use this as page number and we use this as page offset, or frame number and frame offset, and you can perform this division any number of times, isn't it? For example, if I have an n bit number and if I divide it here, here and here, what does it mean? We are breaking it into these many parts, right? So the first part will give you 2 power something. Let us say this is k, l, m, n. The first part will give you 2 power k parts, right? And second part will give you 2 power l parts. Third part will give you 2 power m, 2 power n, right? Then what is the total size of the address space? You multiply all of them, then you are going to get the total size of the address space. And this is what is used in multi-level paging. We shall look at it there, right? So these are the basics I feel are required in order to talk about the addresses and then sizes of page or frame, everything. We shall actually see the definitions now and then some problems on it, okay?